Well, we have seen that the model validator enables us to detect an incomplete criticality constraint, and after fixing it uh, and passing the model validator again, we can see in this example that there are still some modeling errors. All these modeling errors still have to do with modeling rules which have to do with criticality information annotated in the model. If we have a look to the first remaining modeling error, it says that there are several application elements with different criticalities mapped to the same memory space. And it also tells which is the name of that memory space, in this case ms underscore data mining. Well, to explain the problem here, we can show the memory space view, and specifically the diagram where we are showing the allocation of the different functionalities in the platform independent model to memory spaces. To provide a more, let's say, common understanding of what a memory space is in the methodology, we can mention that in the context of software synthesis, each of these memory spaces is translated into a software process, just because a process provides a common memory map to all the functionalities and threads associated to the processes. Well, in a non-criticality aware context, there is no problem in associating an arbitrary number of functionalities or component application component instance to a single memory space. While in a criticality aware modeling and design context, to apply the rule which forbids the mapping of functionalities with different criticality levels associated to the same memory space makes sense. The rationale to that is related to different aspects, like that, for instance, some problems in the handling of memory, some pointers badly handled, could have involvements or implications on the safety level or the higher criticality functionality. So this is not desirable, and it's a common practice to apply a rule like this. Indeed, this rule was suggested by partners that work in the avionics and in the aerospace domain. Moreover, the validation tool has detected two further violations, which are partly related with this specific allocation to the same memory space. If we have a look to the report, it says that these non-critical and these mission-critical components are eventually targeted to resources which have a higher criticality level, in this case a safety critical level. To understand why that's happening, we need to have a look to other perspectives of the model. So if we go now to the architectural view, we can see that the memory space data mining memory space is mapped to an RTOS instance, which in turn is mapped to the CPU4 processing component. This CPU4 processing component is a microblitz component. If just to remind you, when we were assigning criticalities to a processing resource, we stated that these microblitz instances had a safety critical level. So what is going on here is that then we are eventually, on a later term, mapping these criticality 2 and criticality 1 functionality to criticality 3 resources, which are expected to be used only to execute the safety critical functionality. And this is detected as an error by the framework.